very much, everybody. Thanks for a nice introduction. Yeah, so, yes, I'm talking about climate services, but I'm going to start talk more about climate data, which I think many of you are interested in and know about. I'm Tufa, and a senior scientist. Nowadays, I don't like this title. Like Paul said, instead of research scientist, I call myself more of climate service expert. So, but for Colombia, there is no title for climate services expert, so I have to use that title. So, we're talking about climate data in Africa. So, I think the first thing is I have to justify why I need to talk about climate data in Africa. Then I think, okay, what are we doing to alleviate those challenges? But do we stop at data, or do we go from data to information? And going beyond the data itself. I mean, for people in this room, we can stop with the data. But for people outside the room, you need to go beyond the data into product. But even I will show you, even maybe just having the product might not be enough. You need to go beyond the product. I will talk how, and finally, can bring all together to something called enact. So, would be good to make this more of a conversation, and I will. Would be good. You can ask questions. You can complain about my accent, or you can anything you want to complain about is welcome. And we don't have. I have about 20-something slides. We don't have to finish the slides. So we can have the conversation as long as it's the last. We have how many minutes? 40-something minutes?
Yeah. Maybe about 1:45 we should finish, or 10:02 since we got late start.
Yeah, okay. So again, at any point you can stop me and ask questions, or like I said, complain also. So this is me trying to justify what I'm doing in terms of improving the data. These are like different aspects of other people talking about the challenges of climate data in Africa, but even how important having climate data is. Because in this part of the world it is given. Having data is given here. I mean, I was talking to Emma earlier today. She was telling me how much data she has about a lake in here, for how many years. So, I mean, for many parts of the world, that's a luxury. Having that kind of data is a luxury. So, again, I don't want to go. Sometimes this is not just data being available, but even accessing the available data is something, even another challenge. So that's what I want to talk about. Again, this is to justify. So this is from Bloomberg. Them again talking about data issues. Africa being the world's most data poor country. This is from WMO. It shows the station density. How many stations per something. And you see what is happening here, and what you have. For example, you have US here. Almost about 100 or so stations per. But if you look here, it was a good. You are familiar with anybody using GPCC data? Ever heard of it? The GPCC? The GPCC is Global Precipitation Climatology Project. They have grid rainfall. I think now it's 10%, but mostly grid rainfall data going back many years, and many people use this. So this is how many the stations per square kilometer going into that product, the GPCC. This is what you have from Europe and what you have from. Now, for many people who use GPCC and who don't know how many stations go into that product, there is no difference between data here and data here. Because the data you get is complete. It's grid data, it's complete. So for you, if you don't know how the data is created, there is no difference between data in the European data. That's why it's always good to pay attention where does that data come from. That's another thing. Another sad thing is, so the data going into the GPCC been increasing until 1980s, but afterwards been declining. So again, it's a big challenge. Instead of at least going to stay same level, but still decreasing. There are issues of quality as well, not just having the data. But like I said earlier, the paper said earlier, also accessing the existing data itself is a big issue. And I can stand here and tell you a lot about Africa needing a lot of climate information because of climate change, because of a lot of stuff. This. We are okay so far? So now, if you go to a country level, what is the issue? There are many things. One issue is investment. So this is the number of stations for each year reporting data from Madagascar. So you can see like sharp decline in observation. This is from, again, reduced investment or lack of investment from the government side. So this applies to many countries. Another thing that applies to some countries in Africa is issue of conflict. Where there is conflict, there is no observations, there is no data. And once you lose, this is Rwanda. Something happened around 1994, the genocide, remember? And after that, it took them about what, 10 to 15 years to come up to pre-genocide level. So that's another challenge. Conflict is another issue. And I mean, you can't say, not maybe as stark as this, but you can say the same thing about Congo and DRC, Sierra Leone, many of Angola, many of those countries where we have had conflict, and even recently Ethiopia. So here, there are, in a given year, 2 different years, just comparing how much data was reported from each station. So each location is a station location. So it's not bad in terms of distribution. So this is reporting data 10. So the red means almost 100% of the data being reported. Blue means dark blue, no data reported. What's the difference between the two, 2019 and 2020? What's the main difference?
There's more blue in 2020.
Exactly, there's more blue in 2020, especially in this area. No? You see a lot of red here, but here it's mostly blue. Because civil war broke out this part of the world. So you can see like this from 1 year to next year, what the impact of conflict is. Because once the conflict erupts, weather observation is not the priority, is not the first thing people think about. So next one is the quality of the data. Yes, we have the data, but okay, how good is the quality of available data? So we look at the data. This is for rainfall, for example, for different countries. So the black is the daily rainfall. So these red values means what the system identified as. No worry. I have even like a daily rainfall of, for example, 994 millimeters from Kenya. Daily rainfall of 994 millimeters. So it is because of data entry. So 994 is a code for trace. You're like 0, but not 0 rainfall. The trace. So the meteorologist knows. But they hired people from outside, I think university student, to enter the data into the computer. So for the university student, 994 is 994. So. And even here, like I said, 200 millimeters of rainfall in one day is very unreliable. And here, again. So looking at the data temperature, it will be more interesting. Like I said, here you have three. This is minimum temperature, but here you can see clearly minimum and the maximum mixed up. So this is minimum temperature time series. But here also what you see is also this is the missing data. It tells you what happened observation in, what happened observation in. But again, mixing of data. Here's another interesting thing I mentioned earlier. So this is again temperature. But it is daily maximum temperature for this country because the station started here. That's okay. So it's around 20 something here. So this is 20, this is 30, so in between. This is the actual value. For a given year, the whole year, it was over 70 degrees Celsius. Yeah. So it's close to the boiling point. So what do you think happened here? This one is very easy, right? What happened? Yeah, so this, yeah, exactly. So this is Ghana. So during the British colony, they used the British system in Fahrenheit. But later on, they converted the data into Celsius. But somebody forgot to convert this year. And it was in the data system. So unless you have a system, you cannot go through each data and look whether it is right or wrong. So this is, again, I would show you the tool, but anyway, these are the things we look at about the data. So to overcome the challenge, there are two ways you can do it. Go back and fix historical data. Right? And there's the quality, but also the coverage. And the coverage means both spatial and temporal coverage. So how do we do that? So we do the quality. Once we do the quality control, then we do combine the station observation with proxies. We use satellite rainfall estimation and satellite rainfall estimation with gauge observations. For rainfall, for temperature, we are using analysis data. Why can't we use satellite for temperature as well? Why do we switch from satellite to analysis for temperature? Because in terms of measurement, the temperature is closer to what the sensor measures, you know? Sensor measures energy. Temperature is direct relationship with energy. Rainfall is not. But still we are using rainfall for satellite, but for temperature we use. Any idea why? We don't care. So what we do for rainfall, these are station locations, each pixel is station location. This is satellite. Good, after quality control, but does it cover everywhere? Covers everywhere with an estimate. So can we combine the two and come up with combined product? So that's what we do for rainfall. We can generate, help the country generate combined data, combined rainfall station and satellite for kilometers, going back over what now 44 years of time series. That's a lot of data. We have also started doing other parameters, but for now what we've been doing over the last 10 years has been mostly generating temperature and the rainfall. For temperature, like I said, we use reanalysis, but the analysis is because of the resolution of the analysis is coarse. I think nowadays maybe you might have 20 something, but you don't have 4 kilometers like satellite. So you need to downscale this to 4 kilometers and then combine downscale data with the station number. So for temperature, you can go back to 1961 if you want to, because the analysis goes back in time, so you don't go back. Any questions so far? Or any comments? Or helping me in terms of what I missed out? Or, no? Okay. So now, to do this, we need to work with the national mail services in each country. I cannot ask a mail service in Africa, give me your old database and I will improve it for you. They will say, forget your improvement, we will stay with our bad data. So you have to work with them. Why do we need to work with them? Because the data, this is Ethiopia. So these stations, these are about 17 stations that Ethiopia shared with the world every single day. Okay, it's called the GTS is global telecom system. Every country shares the data. Every single day, after every 3 hours. Synoptic hours. So that is about 17 stations for them. But Ethiopia collects even from conventional stations at least 100. And now if you combine automatic with the station, there are stations reporting over 200 stations. Maybe even more, 300 stations combined, reporting every single day. But if you wait until the end of the year, where paper-based reports come in, you will have many more stations. So that's, for us, we need to work with them so that we combine data from all the stations with satellite. Because the more station data you have, the better the quality of the message. Because you can, I don't know if you use chirp program uses the station mostly. Is the merger program. That's why it's called chirp cell. The S part is for station. But they don't have access to all of these stations. So that's why it's very important to work with the countries. So for this, we use what we call CDT, climate data tool. That is a tool developed in-house. It does all of this and more. You can use data organization, quality control. The output I showed you is output from CDT. This is free, available on what's called? Gita. You can download and store and use it. So you can use it for organizing your data, quality controlling, combining the data. Even downloading the data, satellite, analysis, whatever, generate, combine data, evaluate what you have generated, and do some analysis, visualization. So it is very so just to say, with the CDT countries where, at least within Africa, there are other places, but within Africa where CDT has been installed and we provide some training. So the blue ones are where we've been involved in training, installation, and green one done by other than us. But CDT, we also, starting September 2023, we started asking people to register when they download CDT. And we were surprised to see its coverage. Okay. We never thought people in Europe were using it, or even somebody in Australia is using it. Because this tool was created specifically for national services. But many of the users outside are university students. I got an email 3 months ago from a university student in Tehran about CDT. And like I said, sometimes we were very happily surprised to see it's being used. The other one is, okay, yeah, you can help them clean their historical data, but are there areas where you can help them with current observation? Okay, of course you can help them if you give them many more stations, right? But for us, we will just help them to make the best use of the station they have, because nowadays they've started installing automatic weather stations. What I showed you before, all those distribution were manual stations. That's why in Ethiopia, in 2019 you have good reporting, but 2020 not, because it is manual. People have to go and do observation. If it's automatic, it doesn't matter, right? But so that's why now Ethiopia has over 1,000 stations in general, but they have about 200 or so automatic weather stations. But there are issues with automatic weather stations. I mean, they're a good thing because they're automatic, they report data, like I said, but there are some challenges. There are 2 challenges. The first one is maintenance. Okay. because many of those stations are given by donors, and donors is project time life, and then they leave. The countries remain with. Maintaining is not an easy thing. The manual station is manually simple. Automatic electronics requires calibration, maintenance. That's the big challenge, not one challenge. Another challenge is this one. Because the stations are sponsored by different funders, like say World Bank or Bill Gates Foundation, each donor comes with his kind of different type of stations. There are so many different types. Vaisala, Edkin, what other one? Anyway, a number of them, like this one. So here is the Kenya. So Kenya, they have Tamo, Campbell, Sultan, Sep, I don't know, Micro something, Edkin. So which means all this data from all these systems, they don't talk to each other. They sit maybe on the same computer or all different computers. So if you want data from one of these, you have to know which of these systems and which computer, and it's a different format. So even though it is good for Kenya to have many of these data, it's not a good thing for them to manage several different systems. Yeah. So that's where we come up with this tool, what we call automatic weather station data tool. This does all these things. The one brings all the data from all those different in one place, do some data processing, quality control, but also even some visualization if you want to see current weather. That's a web-based system, so you can use it to share current weather information on the current, with current temperature, current rainfall. So CDT for historical data, ADT for, see, let's try what we can. Hello. You're very quiet. Which means you are very nice. You don't ask questions, you don't bother people. So now beyond data, you have that data. Like I said earlier, the data is good for a scientist like you, who can do analysis, research, or whatever. But for the Minister of Agriculture, the person expert in Minister of Agriculture, or in the Disaster Risk Management Commission in Ethiopia, numbers don't mean anything. You need to provide information. It is going to rain, if the rain going to be above normal, below normal. What has been happening over the last 20, 30 years is rainfall increasing, temperature. What's happening? So information, maps, tables, graphs format. That is why, what I'm talking about when I say, beyond data. If you want to do climate services, data is not by such climate services. Data is just a bunch of numbers. And for many people outside the meteorological and the research community, data, numbers don't mean anything. They need to have. So this is our, what we did help each country about, I think we have covered about almost 20 countries in Africa. We do this. So this is a kind of interactive product. We call them map rooms. Here. So climate, for example, if you go inside climate includes historical analysis, current monitoring, also a forecast. Then climate information for disaster people, climate information for water, for health, agriculture. Okay, so from data to product, but don't keep that product for yourself, because the National Base Services, they are happy with improved data. Okay, but it will remain in house. But people outside the National Base Services need to. Number two, National Base Services in Africa, actually even in Europe, they don't share their data. They don't like sharing data. They keep the data very close. So we convince them, okay, keep the data, but can you share the product? And there's a lot of information. I don't want to So this is like I said, the climate, or the climate, this is the historical aspect of it. So historical, if you click climate, you come to climate analysis, and the climate analysis covers all this, just one component of it. It goes from daily analysis. This is a lot of information for agriculture. What's the start of the season? What's the end of the season? Climatological. What's the probability of having this many dry days, dry spell, wet spell, a lot of information. But also your El Nino La Nina. In a given area of Ethiopia, if it's next year's El Nino, what will happen? Or what is the probability it will be? Dry. Or it will be? Or extreme rainfall analysis. What is the probability of having dry or extreme drought? So a lot of information based on the 40 years of data that is emerged from satellite and reanalysis. Now, okay, so you have now the product, data from data to product, okay? Still you are not done. Just stay with the product and those map rooms, you are not done. Number one, you need to tell people you have the product. People need to know that you have the product. But also you need to train users on how to navigate and use those map rooms. So this is the training for national service, training for users in terms of understanding. Sometimes it might sound trivial, but it is not. Especially if you go low-level expert agriculture or water health professionals, they need training, they need capacity development. Now, training is okay, but training is sporadic. You can go and train and then come home. That's it, right? You hope it will continue. But the best way is actually develop a curriculum. A curriculum that somebody can carry on. And this is one of those curriculums that we start. Climate risk management in agricultural extension. That so far we started about 4 or 5 years now. We applied in 6 countries plus 2. And these are the different curriculum materials. And they are now, the good thing about this curriculum is not about developing the curriculum, but they are being integrated into colleges that teach what they call technical colleges that train the extension officers. But also there are some universities now actually started adapting this material. For me, that's a big success. Then me training 100 people, yes, it's a good thing, but it's not enough. But if the university takes on, or the technical college takes on, then it will be part of the formal training process. So we started this with agriculture. We want to go to water. Maybe that's where you can help. Paul's team can help. No, I'm serious about the next step is to adapt this curriculum for 3 areas: health, water, disaster management. The RM is easy because it's mostly about agriculture, so you can, apart from flooding and others, so it's easy. But adapting for health and for water is very important for us. So, bringing all this together, like I said, what I have listed so far, we call it is part of our Enactus approach. This is an initiative I've been leading for almost 15 years now at IRI, Columbia University. So it stands for Enhancing National Climate Services. That's what it's supposed to do. It's about climate information, and it does 3 things mainly: data, product, and use. Let's talk about the data part, the product part, and the beyond product. So the Enactus has 3 components as a climate service. What is data is the foundation. I always say there is no data, no climate service. Right? No? Yes? Or maybe no data, then no this department doesn't exist here. Does this department can this department exist without climate data? Huh?
Yeah.
It will be yeah, I mean, sometimes it is trivial, but data, for me, is the foundation for climate services. But data is the foundation almost for everything, climate. So that's why we start with the data. And then the product, and then what I talked about, and then the curriculum and other aspects of the thing. So those tools I talked about, they are what we call in-practice tools. So there are the CDT part, the data generation part, climate data tool, automatic data session tool. This is the forecasting tool that Paul and his team knows about. I don't know how many of you have used IRI data library. That part, and the map rooms is what I showed you, and the curriculum, when I was talking about some decision support tools. So this comes together as an in-practice tool for in-practice and in-practice tools. I think done. So this is where we have covered in terms of in-practice country. Again, still way to go. We have covered about 15 or 20 countries, but Africa is about 50-something countries, so we need help on this one. And this is what we think we have accomplished so far. Data over 40 years, at least rainfall temperature. The tools, this I showed you. The online climate information product, and then the capacity development. And with
Great, thank you very much, Tufa. We have some time for questions.